Hi, this is Arash and welcome to the Epoxy channel. In this channel, we're going to talk about the epoxy resins from the theoretical aspects to the most practical ones. So if this is the first video that you're watching, or if you're interested in epoxy resins, please like and subscribe to our channel for more videos. Today, I'm going to present Thiol-Mercaptan Hardeners. One of the problems associated to amine hardeners is that they can take up to a couple of hours to cure at ambient temperature depending on the structures, with the fastest amine still only curing in 30 minutes to an hour. Mercaptans are curing agents for epoxide capable of being cured in very short times, for example, minutes or less. The sulfur in thiols readily reacts with the epoxide group even at ambient or subambient temperatures. Thiols improve film quality, production efficiency, and design flexibility of photo-curing resins. Mercaptans cure epoxies through active hydrogen on a sulfur group SH, and typical mercaptan curing agents that are sold commercially have multiple SH groups available for curing. A representative structure of a commercial polymercaptan curing agent has been shown here. Cure mechanism. During curing, thiols are ionized by a base catalyst. The high nucleophilicity of ionized thiol make it highly reactive to the epoxy group. The thiol breaks the epoxy ring to produce a thiolate anion. The thiolate anion undergoes a proton exchange reaction to regenerate the base catalyst. Primary and secondary thiols can both be used as hardeners for epoxy resins. In primary thiols, the carbon bonded to a thiol group is directly attached to only one other carbon atom. In secondary thiols, the carbon with the thiol group is attached to two carbon atoms. The extra carbon methyl group in secondary thiols shields the ester structure. The structure difference lowers the reactivity of secondary thiols, which is called the effective steric hindrance. However, it gives them several performance advantages over primary thiols. In the case of an equal amount of reaction, the mercaptan group has high reactivity, and the thiol structure contributes to flexible properties. In the case of a small amount of adhesion system as a reaction accelerator, it imparts characteristics such as relaxation of conventional curing conditions, toughness, high strain, and high TG. In other words, it can control curing speed and characteristics. Secondary thiols offer several benefits over primary thiols when used as a hardener for epoxies. Some of these benefits are good stability, high water resistance, resistance to acid and bases, strong adhesions, transparency, and low odor. Secondary thiols show better stability than primary thiols. Although their low temperature curing rate is lower as compared to primary thiols, they still offer a remarkable improvement over amine hardeners in terms of curing rate. For applications that require good stability in addition to fast low temperature curing, secondary thiols are a good choice. Epoxy resins cured with primary thiols and modified amines can lose transparency when exposed to water. Epoxy resins cured with secondary thiols show improved water resistance. The extra methyl group in secondary thiols protects the ester structure, giving it higher water resistance. Epoxy resins cured with secondary thiol resins remain stable after immersion in hot water, while primary thiol resins and modified amine resins cured epoxies can lose transparency and turn opaque. Epoxies cured with secondary thiols show good resistance to both acid and bases. Primary thiol cured epoxies can completely dissolve in 5% NaOH solution within 7 days. Epoxy resins cured with primary thiols show good adhesion. For enhanced bond strain, primary thiols can be replaced by secondary thiols. Secondary thiols can increase adhesion strain by 50 to 80% as compared to primary thiols. Some applications require high transparency in the cured epoxy resin. Secondary thiols can be used to produce highly transparent cured epoxies. The use of suitable catalyst with a secondary thiol can also help to avoid yellowing. Residual impurities are the major cause of unpleasant odor in primary thiols. Removal of these impurities after the production process can significantly reduce the odor. The odor of secondary thiols can be reduced to less than 5% of that odor of typical of primary thiols, such as PE, TMP. The secondary thiols are excellent for the formation of stable one-component epoxy resins when combined with a latent curing catalyst. Polymercaptans by themselves do not cure epoxies, though, and require the use of an accelerator, which is typically a tertiary amine such as 2,4,6-tris-dimethylamino-methylphenol or DMP13, benzyl dimethylamine BDMA, polyimidazoles, and ethylenamines. By adding quantities of about 10 pHr of the accelerator DMP13 to the Mercaptan epoxy blends, cure time of about a few minutes can be reached. The more pHr of the accelerator, the faster the cure. Employing lower amount of the accelerator results in a slower curing reaction with lower ultimate hardness of the cured resin. In addition to the gel time being tunable by the amount of catalyst that is added, mercaptans have other advantages that make them extremely useful curing agents for epoxy resins, and the main highlights are convenient 1-to-1 mix ratio with bisphenol A epoxy, excellent bonding to wood, metal, and plastics, gel time adjustable to below 1 minute to over 2 hours, rapid buildup of hardness and other physical properties, outstanding for low temperature application and comparably lower toxicity than other curatives. Not only do mercaptans give rapid curing at room temperature, but they also give rapid curing at temperature as low as -9 centigrade. Even at these temperatures, mercaptans will cure epoxies in under a minute, depending on the catalyst concentrations. Drawbacks. One of the downsides of polymercaptans curing agent is their relatively low Tg when cured with bisphenol A epoxy resins, giving a Tg only slightly above room temperature. This can be overcome by the formulating using multifunctional epoxy resins or Novalox, where Tgs of 50 to 60 are easily achievable with a room temperature cure, which significantly improve the temperature resistance. Because of the sulfur groups present in the molecule, mercaptans have a characteristic sulfur-based odor. Suppliers of mercaptan will often add masking agents, which when combined with the mercaptan give an odor profile that most users find less objectionable. Formulation. Not only are mercaptans easy to formulate because of the 1-to-1 mix ratio with bisphenol A epoxies, but they are also very forgiving in their stoichiometry. In fact, the mix ratio can be off by up to much as, for example, minus or plus 25% and not have this effective properties. The high reactivity of thiols makes them ideal for applications that require a fast cure or curing at room temperature as domestic adhesives and chemical rock bolt anchors. Secondary thiols can be used to formulate one component, 1K epoxy resins, when combined with a latent catalyst. These 1K resins have excellent storage stability and rapid low temperature curability. The latent catalyst is activated by the dissolution of the powder upon heating. 1K formulation with latent curing catalyst help achieve a long shelf life as well as a short gel time, balancing stability and durability. Thiols can be combined with other curing agents such as amines, acid anhydride, and phenols. It is suitable for low temperature epoxy curing system in combination with base catalyst. Overall, thiol system possess fast gel times, forgiving stoichiometry, one-to-one mix ratios, good performance at low temperatures, the ability to bond different substrates, and relatively low toxicity. The secondary thiol has properties such as water resistance and composition stability compared with traditional primary thiols. Secondary thiol show high reactivity, good stability, low odor, superior water resistance, good adhesion, and high transparency. Mercaptans do have their downside though, with low mechanical, thermal, and water resistance, which limits their use in some structural applications. Several products exist in the market. For example, Huntsman manufactures the CapCure and GabePro brands of Mercaptan curing agents. CapCure and GabePro polymercaptan offer exceptionally rapid cure speeds and hardness development with a wide range of properties. The fast cure ones offer cure speeds as fast as 40 seconds to 5 minutes. Thanks for your attention. I hope you enjoyed the video. Please share your thoughts, comments, or questions, and I will come back to you soon. Thank you.